Hello, everyone. Thank you for joining, for coming back. For those people who already attended the technology breakfast. Now, we will get started with the multi-stakeholder dialogue on 6G, exploring security and governance implications of the next generation wireless technology. My name is Wen Ting, and I am an associate researcher with the Security and Technology Program at UNIDIR. So building on the technical discussions we just had during the technology breakfast, in this session, we will delve deeper into the potential benefits as well as risks associated with 6G development, with a particular focus on cybersecurity and also the UN Sustainable Development Goals, or SDGs. Additionally, we will examine ongoing initiatives to establish technical guidelines and standards for 6G within the international context. And today, I'm very delighted to be joined by three excellent speakers to my right. We have Dr. Gürkan. I hope I'm pronouncing your name correctly. Who's a senior lecturer at the School of Engineering of Zurich University of Applied Sciences. Gürkan brings extensive research experience in addressing the security challenges related to wireless networks, including 6G technology. We also have with us today Dr. Maria Matimico-Blue. She is a researcher. She is a research director at Infotech Ulu Institute and director of sustainability and regulation at 6G flagship, a research program in Finland at the University of Oulu. Maria conducts multidisciplinary research on regulatory, technical, and business aspects of future mobile communication systems. And last but not least, we have Uwe Lowenstein from the ITU. He's the counselor at ITU's Radio Communication Bureau, where he supports the work of ITU's Study Group 5 on terrestrial services. Prior to joining the ITU, Uwe also worked in the telecommunications industry, including with Telefonica in Germany. So thank you all so much for being here with us today. We will begin with presentations from each of our speakers, followed by a dedicated Q&A session at the end. If you are joining us online, please feel free to submit your questions at any time using the Q&A function on WebEx. And for those here with us in person, of course, again, you will be given the opportunity to raise your hand during the Q&A session. If you just joined us, please know that this event is being recorded and will be made available on UNIDIR's YouTube channel. However, the recording of the Q&A session will not be published to encourage open and candid exchanges. And with this, let's get started. And I will first turn to Gürkan, who will shed some light on the cybersecurity implications of 6G and also explore potential solutions to strengthen its security and resilience. So Gürkan, over to you.
I think, did I manage? Yeah, okay, thank you. Yeah, so in this talk, I will briefly talk about the cybersecurity aspects related to 6G. So maybe we can go to the next slide. So this is, I'll just skip this self-promotion because Venting already talked about me, but I'm basically a senior lecturer at Zurich University of Applied Sciences. I'm a member of the Information Security Group, and I'm involved in R&D regarding information security and especially future internet, including beyond 5G and 6G networks. So since I will try to cover quite many things in a short amount of time, at least for this part, I would like to give my key message at the beginning. So it will be full circle, which will be also the last slide. So basically, when we look at 6G, It was a very nice presentation by Marie, so I will just refer to it. You saw different applications, different technologies, and so on. We have like 4 important features, attributes of such a system. We have complexity, because we are talking about different technologies, applications. We have scale, because we are talking about a huge substrate or network, which will allow us to do many different things. But at the same time, we would like to have omnipresence. So the idea is 6G is like jack of all trades, providing different services, like, basic connectivity up to advanced services. And then at the same time, we are integrating new technologies, but there are 2 sides here of the same coin. There is the good aspect. For instance, AI or machine learning can provide us capabilities to provide cybersecurity, but at the same time, it can be a potential attack point or attack vector in our system. And finally, we have the criticality, because once we have 6G as this, omnipresent system which provides different services, we also have mission critical services, which will be provided by this system. So why are these important? From the cybersecurity point of view, that means we have a larger attack surface for the malicious agents to exploit. So in the talk, first I will talk a little bit about 6G and cybersecurity interplay, some challenges, and then some emerging, what I call complicators, and then some security drivers, especially technologies and some specific enablers for cybersecurity. So I here call it fortune telling when we consider 6G and security. Of course, there are things going on, as we have already heard and as we will hear as well, but there are things still being discussed. But one thing we know is the architecture of the 6G network will be quite dynamic and heterogeneous. And in such a system, it's challenging to provide continuous security, because you have, again, different components, different entities interacting with each other, providing different services, providing different functions. So when we look at the big picture, again, I'm referring to Marie's presentation, we have these applications, use cases or verticals, however we call them, which are quite diverse, like Industry 5.0, 3D networking, where we have satellites, LEO constellations, UAVs in the air, and terrestrial network providing services. We have things like digital twins or XR, extended reality, provided in this system, which means we have specific security and privacy. I will not talk about privacy in this talk, but anyway, privacy is also there. We have security and privacy issues, but at the same time, we have quite stringent requirements. Again, these are not finalized perhaps, but just representative numbers. The idea is we are going to have extremely low delay, extremely high bandwidth and availability. So once you put this together, you have new security requirements, you have new stakeholders, and at the same time, new attackers, which will try to compromise your system. For instance, you have attacks on 6G architecture. For instance, again, we are going to have something which is really exploiting AI. So you have, for instance, AI native approach for different functions, which means you have security issues or privacy issues related to AI. Or if you have a new physical layer, or if you have an improved physical layer, there are also attacks in the physical layer. And you also have applications which are running using the infrastructure, 6G infrastructure. Therefore, you have specific attacks on those applications. For instance, when we think about e-health or digital health, then you have quite many privacy-related challenges which you need to address. So basically, overall, if you have a breach in the 6G network, you may have, of course, loss of information, the general cybersecurity impact. You may have loss of control of connected devices. So we say these devices are important for us for many different applications. You may have loss of money and property. and even physical danger to people. Because here we have some mission critical systems, for instance, emergency communications. And that means we have this societal impact of 6G cybersecurity. And also, this is important for resilient societies and even for national security. So in the next slide, we see the general threat landscape. I will not go into technical details, just to symbolize what we have in 6G. Not yet, I mean, again, this is a little bit speculative, but we are going to have these different applications, technologies, like we are going to have cloud native technologies where we are using cloud systems, not just like an extension, but core part of the system. We have new consumer end devices. We have intelligence in the network for network management, for many different services. And then you come up with this specific threats. So for instance, if you have AI technologies, that means you have some specific attacks on AI, and also you have data privacy threats. And also if you deploy this in the edge network, you may have physical security issues because they may be compromised. Or if you have, new devices which are supposed to process a lot of sensitive personal data, then they can be compromised as well. So you need new security enablers or security controls. So now, what are the main security drivers? So this is more like an overview or kind of, jumping from topic to topic. So if you look at 6G, there are things like cloud native technologies, AI native technologies, new physical layer, or new radio access technologies, and so on. First of all, once we look at these different aspects, AI and machine learning, ML, are kind of this transversal enabler. So you have distributed and scalable AI in the network for different purposes. It can be just for applications. It can be for network management, at the control layer, application layer, even in the data transport layer. But then you have some specific cybersecurity issues. First of all, robustness. So if you rely on AI models, do you have a robust system? And of course, there is a general security problem. Can, for instance, AI models be tricked by giving false input? Or during training, can you poison them? And then there are also requirements which will make things much more challenging for the network. Because here, we are not just talking AI for the network, but we are also talking AI in the network. So maybe it's not about AI being used for network management and so on, but you have AI-based applications running, which will put a lot of requirements in terms of data security and privacy, which you need to address when you are working on 6G. And there is quantum computing. So there is already, for instance, quantum key distribution technology, which is being used or developed by different stakeholders. But then we will also have post-quantum cryptography. So this is also another important driver or enabler. So there is activity going on there. So the idea is we are going to have this new cryptographic primitives, which are resistant or robust against quantum computing, which are supposed to be able to break, especially public key cryptography systems. And then we have physical layer security. Again, referring to Marie's presentation, Open RAN or ORAN is going to be an important technology, which is an open system, disaggregated system for radio access. But once you have, again, this complex system, there are quite many different potential attack vectors. We have distributed ledger technology, blockchains. I'm not talking about cryptocurrencies, okay? I'm talking about DLT, for instance, for supply chain security. Because supply chain security, especially also from the EU perspective, with things like NIS2, Cyber Resilience Act, very important because we have this global supply chain, and then you need to be, or you need to have trustworthy components, hardware, software in your system. So what are important enablers here? So these technologies are like potential problems and also enablers, of course. So you can have AI for security, for instance, for monitoring, for attack detection, for mitigation, or you can have quantum computing for, post-quantum cryptography and so on. You may have DLT blockchains for supply chain security, but at the same time, you can have, of course, security issues. But there are also some general security controls which we can focus on. The first one is we need better situational awareness because these systems are, again, quite complex, supposed to be quite complex. They don't exist yet, but they are supposed to be quite complex. And therefore, you need to be able to monitor and see what's happening in your system. So we need to develop more advanced and more capable monitoring and situational awareness systems. Another thing that we are working on, for instance, in our Horizon Europe project is resource optimization. Security is not free. I'm not talking about money. I'm talking about like in terms of complexity and energy. So once we have this complex system and once we integrate very advanced security primitives, there will be a cost. So can we try to optimize this so that we have net zero operation? Here, net zero is in terms of carbon footprint, let's say, or at least aim it, and then look into sustainability. And also, there's a typo here, but anyway, we can integrate new paradigms. One is secure by design principles. So instead of bringing cybersecurity into 6G later or as an additional activity, we need to kind of design everything from scratch by considering security. There is also something we call zero trust architecture, which is also promising for 6G. Here, the idea is you don't even trust, your loved ones. Maybe it's a bad example, but the idea is you always need authentication and authorization for any operation in your system. Cognitive systems are also interesting because here you use AI and ML for this better situational awareness, taking decisions, evaluating them, in a closed loop approach. So you can use this for cybersecurity management. This is also something we are looking into. And a general thing is open systems and standards, because once you have this system being standardized or defined, maybe it's not just one standardization body, you need to have open systems. So again, showing my key message, we have complexity and scale in 6G, or we are going to have it. This is challenging for cybersecurity. New technologies will help, but at the same time, they may complicate the situation. And the idea is we are going to have this kind of omnipresent system, even providing critical services. So this is also challenging from the cybersecurity perspective. At the end, we are going to have a larger attack surface. Therefore, we need to look into new security enablers, new capabilities, trying to exploit what is already supposed to be in 6G and also maybe bring in something new so that we have better cybersecurity systems. Thanks. I hope it wasn't too long.
Thank you so much, Gürkan. It's perfect timing, actually. I was counting, and you delivered exactly in 15 minutes. And well, thank you so much for helping us unpack the complexities surrounding the cybersecurity implications of 6G technology or networks. So now let's hear from Maria. And Mario will walk us through the linkages between 6G and the SDGs and also the relevant regulatory landscape. Over to you, Maria.
Thanks very much. So my name is Maria Matinmikko-Blue, and I come from the University of Oulu in Finland. So I'm representing the research community where I've done my whole career. And in my capacity as the Director of Sustainability and Regulation in this Finnish 6G flagship program, I'm bringing my perspective on what sustainability and regulation have to do with the 6G system. So I hope I'll give an overview of that topic. Next slide is an overview of the Finnish 6G flagship. It's the world's first 6G research program that started already in 2018, so several years ago. And now, if you look at the 6G R&D landscape, there are a lot of initiatives globally ongoing. But Finland was the first one to start this research program in 6G flagship. And the idea there is to combine technology research with business regulation and sustainability perspectives and conduct multi-stakeholder collaboration between academia, industry, and the public sector. And then sustainability has been identified as a key driver for the whole 6G R&D. The next slide is an overview of 6G. So I'm starting with this. This is from a white paper. There's a link in the slides that it was the world's first white paper on 6G, published by the Finnish 6G flagship program in collaboration with a lot of experts from different organizations and different countries. So this is available, and it was done in 2019. And one idea there was that 6G will combine communication, traditional communication service, with other services, including sensing, imaging, positioning, locationing, computing, and some other capabilities, so that the 6G system is capable of conducting a large number of tasks using the end user devices, but also using the network. And that then can open up new applications. And this is all targeting the world in the 2030s. And 6G is used as an umbrella term to talk about digitalization in the 2030s. Next slide is then showing, you can't see it very, very well, but 6G is also about resource combinations. So there are different stakeholders that provide resources, and then there are different needs. Consumer needs, industry needs, vertical needs, governmental needs, and so on. So there are different user groups which have distinct needs. And that is already taken into account when doing R&D on the 6G systems. And the stakeholder roles are already changing. So 5G we have 5G today. 5G introduced local 5G network deployments that are networks deployed by different stakeholders. And also, like, those stakeholder roles are changing. So you can have, even today, you can have a 5G deployment with a combination of different companies, different resources. And the same will continue, that there will be different resource configurations to serve different location-specific needs and sector-specific needs, like governmental needs, consumer needs, and so on. And then this slide is about the local operations. So 5G introduced local operators. The same development path will continue. It was a major change, and it was driven by academia, industry, and regulation collaboration. We were very active in pushing this notion that 5G should be made into the hands of multiple stakeholders, not just the big mobile network operators who have their countrywide networks. But then regulators in many countries have introduced local spectrum licensing so that you can establish your own local, if often private, 5G network. And that's the change in the paradigm. Then sustainability, it's a key driver, and this was already agreed in the white paper, the first white paper in 2019. So there the consensus was that we cannot develop 6G without taking sustainability into the center of 6G R&D, especially the UN SDGs, but also all perspectives of SDGs. And then 4 years ago in 2020, we made a follow-up white paper on 6G and the UN SDGs. And you can now, they are freely available, so you can go into the details of that work there. The next slide is then, and these are the 12 white papers we did in 2020 and 2021 in collaboration with all key stakeholders of the telecom sector. And the next slide then goes into the role of sustainability. So that's my favorite topic, and sustainability means different things to different people. I like these old definitions, old work from 80s and 90s, that sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So, and we have to consider economic, social, and environmental options so that we don't limit today what is open to future generations. I think this is quite commonly used terminology, but still there are a lot of definitions. If you look at the research on sustainability, there are many definitions. And the sustainability, when it comes to mobile communications, it has to change the fundamental thinking there, because today countries are ranked according to the total consumed mobile data. Finland is a forerunner because we consume a lot, but that's totally against all other sustainability discussions and thinking that we have. So still I claim that the mobile communications has not really adopted the sustainability thinking when we even talk about the metrics that we use today. The next slide is then the SDG connection. To your disappointment, I only have one slide about the SDG connection. The connection is bigger than this. But if you look at the SDG framework, the goals, the targets, there's only a handful of targets where the indicator is ICT-specific indicator. There are 5 ICT-specific indicators. There used to be 7. I don't know what happened to 2 of them. They're not monitored anymore. But they are like I have to look here. Proportion of youth with skills, ICT skills. And it's like proportion of population covered by a network. So those are the kind of ICT-related indicators in the SDG framework. So it's not very, very deep connection. But there is a connection. So the ICTs, the digitalization can enable a lot of things. And the enablement of the ICTs can then help the achievement of many of the targets of the UN SDGs. So that's my main message, that even though there are only 5 ICT-specific indicators, which are like high-level indicators, proportion of population covered by a network, still digitalization can play a huge role to support in the achievement of many sustainability goals. And the next slide is then about the way I see the role of ICTs and sustainability. So as I mentioned, digitalization can enable a lot of things. There can be a lot of positive impacts in different sectors of society. They can be about making operations more environmentally friendly, making them more efficient, like optimizing a certain area with like traffic area, which can then reduce consumption of all kinds of resources. So we can do a lot with digitalization, and this so-called handprint effect is also called the second order effects. That enabling role is very important. And we talk a lot about the enabling, the good that can be done with digitalization, but that's only one side of the story. At the same time, ICT solutions and services, they create enormous burden on environment and on social parts. And I want to emphasize that environmental, social, and economic sustainability perspectives that they always have to consider. Today, there's a lot of e-waste generated by people, especially in Europe. Europeans consume a lot of ICT gadgets, handheld devices, terminals, TVs, electronics. There's a lot of ICT e-waste being generated, and only part of that is properly recycled, and so on. So there are a lot of challenges in terms of the ICTs. Energy consumption keeps increasing. ICT's energy consumption is not decreasing. We're talking about AI, data centers. We're already now seeing that the energy consumption keeps increasing, and we can't just talk about renewables. Oh yeah, we use the renewables. But if it means that other sectors are left without those renewables, then it's not really, we can't really justify ICT sector's own operations such that we use the renewables. Then they are left, then others cannot be using them. So it's important to consider these two roles, so that the ICTs themselves consume less, emit less, use resources more efficiently, and at the same time they enable more in other sectors. So maximizing these positive effects while at the same time minimizing the negative effects. And it's a difficult thing. It's a very complex equation, and that calls for identifying the indicators. What are the actual indicators for environmental, social, and economic sustainability? How to measure them, how to assess them. I don't even talk about measuring because I have it here, but measuring is challenging. Assessing is probably a better word. Requirements and design principles for these sustainable solutions. So this is ongoing, but it's by no means ready. The next slide is then, this is an example of environmental sustainability indicators. Here the list is already quite long. Energy consumption, energy efficiency, carbon emissions, and then a lot of the materials related things. But at the moment, regulators do not collect much of this information. Like only some countries collect some information. So there's very, very little that is being collected. But there are initiatives in Europe that this should be happening. But it's globally, it's very, very divergent. There are countries who couldn't care less about this. And then there are, like in European countries in general, there is interest to to promote this, but still there's a lot of fragmentation between the countries. And the next slide, and here I just list that there are a lot of concepts, and I'm just mentioning this ITU-T recommendations. I was not doing this recommendation, but it has nice terminology about this impact of the use of ICTs in different sectors. First order effects, the own ICT's own environmental impacts, enablement effect, positive and negative, and so on. So it's a complicated picture. Next slide is then about the regulatory framework. So what's happening in terms of, you can go to the next, the regulations. So the previous. So Uwe will be introducing the ITU work in more detail about the IMD 2030. The global framework has been published last year. And we already talked about that the spectrum earlier today, that spectrum is a key thing. And those discussions are ongoing. Any wireless systems requires access to radio spectrum. But since that's already given to different types of use, it's hard to get unused spectrum for 6G, and those debates are ongoing very much. And then a lot of R&D effort is ongoing on the, to still go back. A lot of R&D effort is ongoing in 6G in Europe. For example, the European Commission is funding a lot of projects under Smart Networks and Services Joint Undertaking, which is a collaboration effort between the Commission and then companies. So there are like tens of millions of euros is now, today as we speak, being invested in 6G R&D in Europe. And then the sustainability thinking is coming there, but it's still far from being a reality. And then on the right hand, I have the box just to indicate that we have 3 layers. We need the infrastructure and network, but that's not enough. People need access and connectivity to the network. And even that is not enough. We still need services, life-enhancing services and relevant content in the language that people can use, in a way that people can actually use. So we need all these 3 layers: infrastructure, access, and then the services. If one is missing, we still fail in the big picture. The next slide. And these are from that ITU work that Uwe will tell more, but I just wanted to mention that networks will enable services. They can also collect sustainability information. So the ICT infrastructure in the future can collect sustainability information, which can then be used for various purposes. And the next slide. So I will skip these because Uwe will mention them, but these are the globally agreed usage scenarios and frameworks and capabilities. And sustainability is there. Yes, next. And I jumped to these global things. So a lot of agreements exist to promote sustainability. One is between EU and the US in their Trade and Technology Council. And I put it here because I really like this statement of how sustainability is written here. 6G answers 6G. 6G is an enabler for sustainability, considering environmental, social, and economic perspectives. We should aim at reduced carbon footprint and improved energy efficiency and reduced energy consumption across all sectors to support long-term social sustainability while maintaining economic feasibility. The next one. So then the collaboration, and this work is about collaborations. In the white paper 4 years ago, we draw this picture about different stakeholders. I come from academia. Governments play a huge role in defining the requirements. End users, verticals are also critical because they define how the technology is being used. But the ICT industry itself develops these solutions. And they develop that in collaborations that they do in the standards body. So all have their own role in this big play. And the next slide is then these are my statements about this collaboration. So the collaborations benefits everybody. But coming from the research domain, I claim that many researchers highlight freedom. We want to be free and we want to investigate whatever we want. And they rarely consider inputs from regulation. Some work very closely with companies and regulators, but not all. So when I try to talk about that regulations say this, they tell me that we don't want to hear. We want our freedom. So there is this kind of gap between many researchers and then what is going elsewhere. There are silos. And now in 6G development, we are talking about values-driven technology development in Europe. it's part of these European 6G projects. And that calls for multidisciplinary approach and multi-stakeholder collaboration, that values, European values, should drive technology development. But it's hard for engineers because the values are something that they have not studied in their degrees. So they do need multidisciplinary approach there. And the stakeholder research domain lacks the incentives for this. Research merits are publications, funding, research funding. Tenure track positions are about certain things. They don't emphasize regulation collaborations, governmental collaborations. So the whole way the research sector works is not incentivizing these kind of collaborations. And then the final conclusion slide. So 6G, you hear it all the time. If you look into the future, it's an umbrella term. So it's a technology that it's a mobile communications technology. But under that, we talk a lot about digitalization developments in the 2030s. And radio spectrum, I didn't touch it so much here, but it's the fundamental key asset, and it's the source of a lot of conflicting stakeholder views. And there is agreement that sustainability is a key driver for 6G R&D in order to minimize negative impacts and maximize positive impacts on environment, people, and economy. But it's a new thing to most people. It's a new thing to most researchers. And it still takes time to really incorporate this into if you've done something in the same way for 20 years, and now you're told that, oh, consider this. It takes time, and it's challenging to change your existing ways of working. But this really calls for a change in mindset and a new ways of working together in a multidisciplinary and multi-stakeholder collaboration. I stop here, and I'm open for any contacts. You can ask me even later.
Okay, there we go. Thank you so much, Maria. Thank you for your insight into the sustainable aspects of 6G. And also, you touched upon a very important issue of collaboration and also interdisciplinary research. So I think this is definitely a very important aspect for moving forward. Well, we will now hear from Uwe, and he will focus on the importance of standard setting in 6G development, and specifically Uwe will talk about ITU's recent work in this area. So Uwe, the floor is yours.
Yeah, thank you, Wenting, for this introduction. And yeah, I'm trying to provide you an insight in IMT 2030, the work we are doing with our membership. And just the first two slides, if we continue, the one more, please. ITU is one of the 15 UN specialized organizations. We are responsible for the allocation of the global spectrum, also the coordination of the satellite orbits, and I will have also two slides for you for the non-terrestrial network aspects of 6G, but also for the technical standards to develop in the according specifications. If we look on the next slide, we have three sectors within ITU, and when you click, you see very soon that there is one section which is dealing with the World Radio Conferences. And why I'm telling you this, because the World Radio Conferences, they will update when you click on the so-called radio regulations, which describes which part of the spectrum is used for which service. So whether there's a broadcast service, whether there's a mobile service, whether there are satellite services or research services. And this is important, which we will see soon, what spectrum is allocated in these radio regulations to which service. In parallel to the World Radio Conference, we have the organization for your complementary information. If we go two slides further, please. Let's look into ITU. We have the IMT generations. There's IMT 2000, which was developed back in the year 2000. We have IMT Advanced, IMT 2020, and we are now talking about IMT 2030. And when we click on the slide, you will see that this terms is ITU internally, whereas the market is referring to 3G, 4G, 5G, or just in April this year, 3GPP has also agreed on the logo for 6G. And as you can see very nicely, in the middle of each of these boxes, the certain generations, they have different, they are called radio interface technologies or standards. And so, as you can see at the very beginning, as has been also said by Maria, there have been 7 standards incorporated. In the latest 5G version, we have 4 radio interfaces coming from 2 different standardization fora. And of course, we at ITU are also interested in what is going to be the part of IMT 2030. And I will explain you in the following slides. This is the overall, we call it IMT timeline and process. And you see, we had started already back 4 years ago or 3 years ago in around the year 2020, when we click with the first box, and the first box would be the framework. And in the framework, we have defined what the future technology trends are going to be. We have also developed a recommendation on the new framework, which is actually the basis most people are working right now. But we have also a report of feasibility in frequency spectrum above 100 gigahertz, which is a completely new frequency area for the mobile communication services. As I said, we have passed this framework. We are now in the phase of requirements and evaluation criteria, because you will see we have sent, when we click out actually from the last meeting, a circular letter, we call this, to the membership and this is very important, to external standardization fora, to inform them that by the year 2027, ITU would expect the submission of according candidates to be proposed for IMT 2030. Meanwhile, in the next 2.5 years to come, ITU, again together with its membership and the external organizations, they will define the requirements, the minimum technical capabilities, as well as the evaluation criteria. Then we will schedule a workshop around the beginning of the year 27 to have all stakeholders, let's say, brought on one level in a briefing. And then we have another 2 to 3 years for the evaluation and consensus building phase, where we will try to narrow down the proposed radio interface technologies to as less as possible, as I can say that, radio interfaces at the very end. And around the year 2030, when we click, we will see there is the parent study group, again 2 clicks please, agreeing on the specification, and this will then be approved by the ITUR study group 5 and sent to the membership for their approval. This is the overall timeline. And when we look what we have done so far, we have the future technology trends. I leave the details for your information. When we click, we have the document which is also talking about the feasibility of IMT above 100 gigahertz. And in the presentation, I have provided all the information and links for your further details if you want to look in more detail. And what I would like to focus on the next 4 slides is the so-called recommendation 2160, the new framework. On the left-hand side, you see the main body with the preamble and the normal terminology ITU is considering, recognizing, and then very important, recommends. And then here you have the annexes. What does it tell us? When we see, for instance, after a short click, chapter 2, it provides us information why IMT 2030 is needed. We heard some aspects this morning by Maria, but also what are the expected benefits is elaborated in this document. We will also read the trends and prospects of 6Gs and the according features. Chapter 3 will provide the guidance on these 6G features, and chapter 4 has been written here, will provide information about the capabilities and how to fulfill the usage scenarios, which I will show you on one of the next slide. And then at the very end, we have the relationship, which is very important, with existing IMT generations, but also the roadmap and communication with the external standardization fora. Without them, ITU would not be able to agree on the final IMT 2030 specification. The next slide shows in detail the according sections of this important chapter 2. We have motivation and societal consideration. We heard about sustainability and security, but of course, ubiquity is, to my understanding, a very important aspect of the next generation to provide access for the underserved people or not served people. And I just heard about the latest results, which we have been published in ITU. I think this was back in September. And the figure was surprising for me. 2.5 billion people in the world are not connected. And this is a very important aspect, I hope. I mean, I cannot influence. I'm maintaining the work. But I hope that this will be addressed by IMT 2030 6G. We have the 9 user trends and application. Again, we have the sustainability, which has been very nicely explained by my colleague Maria. Then we have digital health, well-being, again, the ubiquity, but also this digital twin and virtual world, to my expectation, will play a big role to have virtual access to the network and not the way we have it right now with, let's say, one-to-one physical communication. We can click 2 times, then we will see the different chapters. There are the technology trends, which are explained in chapter 2. And then also there's some elaboration about the envisaged frequency bands and needed spectrum harmonization. As I said in the beginning, this is being done at the Quadrennial World Radio Communication Conference, and the next one is scheduled for 2027. And we have several agenda items addressing potential new frequency bands for the terrestrial and, very important, also satellite component of the future IMT generation. The last box here on this slide shows that we have this above 100 gigahertz. Of course, this frequency spectrum will not be used in the rural areas, but in particular for indoor and for device-to-device communication. There are possibilities that these frequency bands become very beneficial for the next generation of IMT. Let's have a look at the according information we see in the usage scenarios. And this chart on the very left, it's, let's say, the extension development from the triangle you see in the very middle. We now have 6 usage scenarios and not 3. So 3 are extensions from the previous generation, IMT 2020. And we have 3 new usage scenarios. Again, ubiquity connection, integrated sensing and communication, which will be also very important. But also we heard it from Gürkan that there is the artificial intelligence being part and especially becoming a usage scenario for this next generation. And all around, when we click, we have 4 overarching aspects. And you see on the bottom right, if we click very briefly, there's also security and resilience. And this is important and an aspect of IMT 2030. On the next slide, click on the next slide, we have the capabilities to implement the usage scenarios. Again, here it's a combination of existing enhanced capabilities, which you see on the lower bottom in green. And this is, as also has been nicely explained by Maria, higher reliability, lower latency, higher throughput, higher mobility. But we have also here in this recommendation 6 new capabilities addressing the need for an increased environmental, social, and economic sustainability. No, it's okay, you can continue. It's fine. So we have relationships and timelines defined in chapter 5. As I said, we have a lot of communication, and not only now when receiving the potential candidates by 2027, but also in specification of this recommendation, we had a lot of communication with external organizations and standardization for which makes the work of ITU very important. Another chapter in chapter 5 is when we click the timelines. So we have this timeline to be around the year 2030 finalized with these specifications. And again, you see here that there is the spectrum implementation which runs in parallel. And I can tell you, you will see in 2 slides further, but first we go to the next slide. On the satellite aspect, there is and has been always a NTN, non-terrestrial network aspect in all the IMT generations, but in particular in the framework for IMT 2030, it is explicitly written that there will be a non-terrestrial network component to complement the terrestrial aspect. And how can this be? We see when we click once, please. There is some, how to say, development already back since IMT 2000, and what this is going to be related to IMT 2030, we will see on the next slide. We have to have the timeline. On the right-hand side, you will see the timeline for the terrestrial component of 5G, but we are talking about IMT 2030 or 6G here. And when you click, you will see that the timelines for both of them, they are aligned. We have the 3GPP timeline actually starting with release 21, where we have the first contribution and essential parts for the normative phase. Release 20 will provide initial material. And on the lower bottom, the two streamlines for the terrestrial and the satellite component are those who will be aligned towards the work for IMT 2030. And on the last slide, I try to share some aspects with you regarding this non-terrestrial component of IMT 2030. There is new radio and Internet of Things. These are two different use cases which are also dealt differently within 3GPP. Then there's the spectrum question. Where should this non-terrestrial network component be deployed? Should it be in the IMT bands? Probably a lot of you have heard direct-to-device connectivity. So this is what ITU and the industry is working on. But at the same time, there's dedicated mobile satellite spectrum where this NTN component could be deployed. Two further questions we will see after the next clicks. And this would be, where would it be, the satellite systems? Is it a GSO satellite orbit, or is it a non-GSO? We call them also LEO, low Earth orbit. Is it a IMT technology, or will it be a complementary technology? And several others relevant assumptions which you can find in the according references I provided you in the annex. In the summary slide on the next page, you see ITU has a vision and a framework, but not only with a terrestrial component, but when you click also with the satellite component, and also after another click with the broadcasting community, and the according references are provided here. And last but not least, we have beside the ITUR sector, we have also our colleagues from the T sector for telecommunications, where the non-radio aspects, for instance, including security, but also including the fixed mobile and satellite convergence, are being addressed. In summary, on the last slide, I think this recommendation 2160 provides the basis for the further consideration of IMT 2030. We can assume that there will be a satellite component approximately around the same time frame available for 6G as we have the terrestrial component. And as I elaborated a couple of times, it is important for ITU not to work with its membership, but also to work with the external organizations, standardization fora like 3GPP, but also like all the research institutes, because without them, we wouldn't even have set the minimum requirements and the capabilities. With that, I would like to thank you for your attention and happy to cover any questions.